Hello everyone, welcome to MLAS650. We are jumping into Learning Activity 4, Setup and Testing of your microcontroller hardware. Up to this point, you should have completed Week 1's learning activities. That's going to be course overview and getting started, overview and applications of autonomous systems, and then acquiring your microcontroller hardware. So that should wrap up Week 1. Now, we do have some students that are coming in as late course adds. That's okay. If you happen to be one of them, you will be okay. At a minimum, if you have your equipment, your microcontroller equipment this week as of right now, then you'll be great. You'll be in good shape and you'll be able to follow along in today's exercise. However, if you happen to, at maximum, get your microcontroller hardware later this week, no worries, it will still be okay. You just might have to do a little catch up to get going in that regard. Okay, so this is our first big lab. This may take about 30 minutes. I'm going to try to keep us moving along as quickly as possible through this this lab. It's one of our bigger labs just because we're doing setup and testing. And then later this week, we'll have key components of autonomous systems lecture uploaded, as well as the architecture frameworks and methodologies lecture uploaded. We do have a research, our first assignment here, assignment number 1, research project title and abstract. That will be a very straightforward project assignment. So it's worth 10 points. I will have that uploaded, I will have it released here after this lecture, so you will be able to see what it is about, so you can plan for that. It won't take too long. You'll actually spend a little bit more time noodling on what it is that you're going to write about, but it is a project title and a simple abstract. So no more than 250 words on your abstract and a very short research title for your project. And it's going to be focused on an autonomous systems project. Autonomous systems architecture project. So more will be covered in that, but you'll have plenty of time to work on it for the weekend. And then of course there's unlimited submissions and more research direction, or I should say more assignment, more directions on the assignment rather, will be posted here later this week. Okay, if you have any questions on that, feel free to email and or text me. So my information is published in the syllabus. Again, any questions, feel free to text or email. All right, let's go ahead and jump into the lab. First up, I want you to navigate to this website. It's the learn.adafruit.com, Adafruit Circuit Playground Express. It's this quick start guide. If you do an Adafruit Circuit Playground Express quick start guide, you should find a link to that. So this is the way to get there. If you are not familiar with what the microcontroller looks like, this is what it is, and this is what you'll be working with. Of course, that's just a shout out to the students that don't quite have their Adafruit microcontroller yet. But those that do, that's going to be familiar territory for you. Okay, with that, what we're going to do, one of the first things that we have to do in setting up our microcontroller is flashing it with a new bootloader. So this allows us to use the Python programming framework on our microcontroller. If we don't do this step, then it's going to make following along in our process and our class a lot harder. So navigate to this web page and just kind of get familiar with it. There's a simple set of instructions that we're going to be running through. I'm on a Windows operating system, so if you are on a Mac, that will be a different, that will be running, you'll have to let me know, but I believe that the instructions are going to be very similar. So for those Windows users, I'm going to be using Windows rather, and so we'll be going through and learning that on how to program the microcontroller using a Windows framework. Okay, first up, go ahead and connect your microcontroller. And I'm going to actually, I've got it loaded up here. I'm going to bring mine over here and have this, I'm going to expand it. I already have mine connected. So this is what you have. This is what you should see. Make sure again that you've got a microcontroller cable, data cable. It's a USB, micro USB cable, and that I have personally got it connected to my machine over here. It should be ready to go. And the way we know that it's ready to go is when you connect your microcontroller. And I'm gonna move this. Oops, I'm gonna move myself off to the side here. Make myself a little smaller. Okay. I'm going to open this up over here, and then all right, here we go. And I'm gonna make sure that this is something that we can see on the left hand side. So you're gonna see this C Play Boot. C Play Boot drive. That lets you know once you connect up, you should see the C Play Boot. Now, this does not allow us to run Python code. So the first thing we have to do is we got to come over here, and then we've got to download this code. So I'm going to bring myself off. So you'll download what's called this UF2 now. This is going to allow us to run. It's a very small file, and I'm going to go ahead and navigate over here. It's this file here. Now, what we want to do is we are interested in taking this file that's over here, and we're going to drop it into this C Play Boot over here. It's really straightforward. Now, I want to bring this over and so that you can see what ends up happening when I do that. So I'm going to have this up on the screen. I'm going to come over here, and I'm going to drag this over to C Play Boot. That's all we're doing. We're just dragging this over to C Play Boot right there. So when I do that, it's going to bring up, it's going to do a lot of fun stuff, and then that's it. It's done. It's going to switch to this, what's called CircuitPy. Once that's done, you're good to go. So now I'm going to move this microcontroller out of the way, just temporarily. And that's the hard part. Now, let's go ahead and move this over here. That's all you need. Now, know that if this ever changes in the future, or if something gets messed up, or you can always redo this and you won't hurt anything. You can't break anything unless you stomp on it with your shoe, and then you might, if you end up. These are pretty hardy. I've dropped these on the floor. They're real light, and they don't have any, I mean, I've seen them not, they can take a beating. Now, if you step on them and crush them, then that's a different story. So avoid doing that. Now, let's go ahead and move. Whoops, I don't want to move my screen. I want to move this back over here. Back to the CircuitPython. This is a library that we are installing onto a boot library that we are installing onto our microcontroller that allows us to run Python programs. If you want to review, there are additional instructions here. They are the same instructions. This is just for your reference in case you missed what it is that I did. You can come back here and review it. Okay, now once that's in there and we're good to go, and we've gone through, we want to install the Mu editor. Mu is a recommended Python editor, and you're going to go over to this link, and you're going to download Mu. Now, I'm running on Windows. There is also a Mac OS installer. You can run that, and then I'm going to go ahead and do Windows. And I've already downloaded this, so I'm just going to go ahead and jump straight to that. Okay, now that once it's done and downloaded, you're going to want to take this and double click on the Mu editor, and you're going to get this welcome to the Mu editor setup. You can go ahead and hit next, go through the setup procedures. I have already installed it. It's pretty straightforward. Just hit next and do a default installation, and you'll be good to go. And then I'm going to go ahead and run through that and skip to the end. And then what I'm going to have here is this, I'm going to just finish this setup, and then I'm good to go. Okay, now that that's been installed, one of the things that I can now do is run, I can go ahead and run the Mu editor. And the easiest way to do that, once it's installed, is I type in Mu editor right here, and then it'll pop up. So on a first install, I'm going to talk through it, but on a first install, it does take a little bit of time for it to get installed. So, but since I've been running this a couple times, I've already got it installed. It'll pop up pretty quick. But don't worry, if yours takes 10, 15 minutes, it's okay. It does take a bit of time on a first installation to get booted up. Now, once your Mu editor pops up, one of the things that you're gonna get presented with is this mode. It may automatically bring up the mode for you on the installation. And there's a lot of different things you can do here. There's Pygame, Python, Raspberry Pi, Flash for microservices, BBC microbit, ESP for ESP32. Those are really small microcontrollers. Those are fun also. But we're going to be working with Circuit Python. It's this one right here. We're going to be running with that. And once you hit that and hit OK, and you don't get any error, that means you're in good shape. It means that everything is running. So I'm going to bring back this over here, maybe to the top of the screen. I think that'll just about do it. So I'm connected. I'm good to go. And so then what we're going to do is I'm going to come over here, and then I'm just going to write some basic Python code. So this is basic Python code. So when you're running Python code, that pound symbol, that's a comment. So it means that it's a comment that is added to our code that isn't executed. Now, I'm going to write a very simple program. It's going to be, I'm going to print some code. I'm going to create a print statement, and that's it. That's our first Python code, 1 + 1. You could also do, of course, our obligatory hello world. And then we'll run these too. Now, I'm gonna do something here on this. And then I'm going to take this and I'm going to upload it, and you hit it by hitting the save. I'm going to upload, and then you'll see nothing really happened. It kind of did like a little blinky, but that's not really helpful to us. So what I want to do is get you a little more familiar with what we're going to be using regularly throughout this IDE. You'll notice mine is a dark thing, so a dark theme. So I have a dark theme. So you'll notice here I can switch my themes. I can go from bright. Yours may have gone into the bright. So then my theme is kind of this middle ground. This is dark. This is like very dark. But I'm going to do the middle theme. The other thing that we're going to be using a lot of is this serial and plotter. So in addition to save, we'll also be doing serial and plotter. So let's go ahead and put serial up. And then I'm going to go ahead and rerun my code here and see what happens. So you'll notice down here that this serial, I get an output right there. So I ran my code, and then I ran this print statement that did 1 + 1. I got 2, and then I did another print statement for hello world. There we go. And that pretty much just takes care of what it is that I need to do. So if I rerun it, if I do this again, and it looks like I've got something interesting happening on my NeoPixel. So let me go troubleshoot that real quick. Okay, I think I'm back. So I did something here where I'm not sure how I did this, but what you can do on this console here is if you click on the console, I figured out what happened. If you clicked on this console by accident, that's okay. that gives you this access here. I'm gonna Control D, and that will and I'll do Control D again, and that resets it. So what happened was I accidentally hit something over here, and then it interrupted our program code. So if that happened to you and that lit up, then that's what happened. It's okay. You can reload it and reconnect it, and you won't have any issues. All right. So now that we've done that, let's go ahead and actually do something and do some plotting functions. I want to test out the plotter because I want to be able to access, I want to be able to do more. So let's go ahead and type some code out. And what we're going to do is something a little bit more complicated. So I'm going to create what's called, I'm going to access what's called Python libraries. And Python libraries, for those that are not big on the computer piece of it, it's okay. You'll be all right. We'll get you through everything you need to know. If you're not familiar with computer programming, it's okay. I don't need you to be a computer scientist. I don't need you to be a mathematician. You will get through this. As long as you have some base computer skills, we'll get through this. Now, what we are going to do is a Python library is a lot like walking into a regular library at your bookstore, and we're accessing some information. This is no different, but in this case, it's computer information. So what we're going to do is we're going to be accessing a book within the library. And in this case, it's going to be a time. We're going to access some functions and then import time, and we're going to import random. So these are two. Think of this as we're walking into the bookstore. We're getting a time library, and then we're getting a book rather, a time book, and then a random book. So in this case, they're going to be chapters that we access within this that give us special features that we can then run as program code. So in this case, we're going to do a while loop. So this is our actual Python program, and then we're going to do while true, and then we're going to say time. So this is the time library, and so this is the time book within the library, the book library that we're borrowing. So we're going to get the time book, and then we're going to access what's called the sleep chapter, like a chapter within the book. So in this case, it's a sleep function. So it's sleep. So in other words, for this program, we're going to do 0.05, which means that we're going to sleep. We're going to pause the while loop. Pause the while loop for what I guess in this case would be 50 milliseconds because of where the decimal place is at. If it was 0, and I'll explain this, if it's 0.5 like that, then that's 500 milliseconds. 0.5, that's in the 100th place, so that means it's 50 milliseconds. So that's what that would do. Okay. Yes, correct. Got it. All right. Now, next up, I'm going to do a print statement, and then we're going to use the plotting function here. We're going to open up the plotter, but we're going to print data to the plotter. So in this case, with mu, it's pretty easy. We don't have to do anything other than we're going to access the random library book, and we're going to do a rand int. So we're going to do the chapter that is within that book. We're going to access the random int function. So there's a feature in that chapter that we want to access, which is 0, 100. And then we're going to do that, and then I'm going to copy this over and over again. So I'm using Shift Control, and then that allows me to Shift Control arrow, left and right can allow me to do that. You can use the mouse also to do that, but I'm going to do Control V and paste that in, and then I'm going to Control V again and paste that in. Then I'm going to do 2 more parentheses, and I think that'll just about cover it. I think 1, 2, 3. I think so. Correct. Let me just make sure. Random rand int. Yeah. Okay. So this ran it 0 to 100. Then I'm going to create another set of numbers here that is going to be negative 100 to 0. And then this other, I'm going to do negative 50 to 50. Okay, and then what that's going to do is I'm just double checking everything and making sure that's all right. Looks correct. Now, I'm going to open the plotter up here, this thing right here. I'm going to hit the plotter feature right here, and then I'm going to go ahead and load this up to my controller. We'll say save. It's going to code done running. We'll load it up again. We'll try it again, see if this, I might have an error here. I do have an error. It's actually related to some syntax. I've got some incorrect syntax I got to check here. Hold on. Okay, I think, here's my mistake. I've got too many parentheses. That's the problem I got. Okay, there we go. Okay. So you may have seen, let me just back these out. So if you see these parentheses in front of the random, I put too many. There we go. I copied too many parentheses in. So we know that our code's good when the parentheses match like this. So you can, that parentheses matches that one matches the outer one, and this one matches the outer one. So then we should be good to go. Okay, now that we've got that taken care of, I believe we're in good shape. So if I redo this, I'm going to upload this code, and then we'll see if we can get this to work. Okay, perfect. All right, we're going. Perfect. I'm going to minimize this a little bit, and I'm going to come over here and bring this down just a little right there, and then bring this out. So we're running. We're actually on the microcontroller. We're actually running code, and we're using the microcontroller, and we're outputting this code back to the computer, and we're doing this in a random fashion here. This is all cool. This is all good. And this tells us that we are actually running, we're doing something. It's random. We're running some basic Python, and it's working just fine. This is looking good. This is looking okay. I don't see any issues. So all right. Okay, so next up, I'm going to leave that there. And the next thing we're going to do is we're going to actually do something that accesses the thermometer. We're going to actually we're going to access the sensor that is on our Adafruit microcontroller. And the sensor is actually, it works just fine. It works perfect. We're actually going to do a test and then go through a basic tenet of an autonomous system through our setup and config that we're doing here. Okay, so now that that's done, we're gonna create. I'm gonna take the serial plotter. Actually, you know what? I'm gonna leave him up. So let's pull him back up. Okay, so if just as an FYI, if you hit these again, you can make them go away and come back. So for example, if I hit the plotter and then hit the plotter again, then it'll come back, and that'll be, it's okay. You didn't delete any data. It's all right, just as an FYI. Okay, now that we've got that data running and we've confirmed that this is working, we're going to actually go and do this thermometer program. So go ahead and save this off now that we actually have that working. Because we're gonna now create a new, we're gonna do a new one here, and we're gonna create a new program. So first up, you can leave this running. That's what's kind of nice about this, is you just let it go. And one of the things that we're gonna do differently here is we're gonna delete all this, and we're gonna create another program but this one's gonna access fruit. This is going to access 3 books from the library. In this case, the time book, and then we're going to access the Adafruit book. In this case, thermistor, and then import board. So this is a time book that gives us features. This one gives us access. This gives us a book of knowledge as it relates to the thermometer, and then the board is actually what gives us access to the board itself, and the sensor package that we have. Now, we're going to create something that we're going to do here is we're going to create a variable, create a thermometer variable. And this is going to be something that we create that saves the data for us. So you see all this telemetry data that's running by. Well, in this case, what we're going to do is create a variable and save the thermometer sensor data to a variable. So this is thermistor, yep. And make sure that your spelling is correct here. So we're going to access the Adafruit thermistor book, and then within that book we're going to access a chapter called that gives us a feature, a book of a chapter of information. In this case, it's the thermistor feature. Thermistor, and then we're going to say board, and this gives us access to the board book, and then temperature, and then we'll do 10,000, and then I'm going to copy this actually, 10,000. I'm going to copy it a couple more times. In this case, it's going to be 25 for this position, and then it's going to be 3950 for that position. Okay, so so just be clear, I'm not asking you to understand everything that's going on here. I don't need you to. I'm not looking to crush you on the details of everything. I'm not. Again, I know that everyone's not a computer scientist here. Some have electrical backgrounds, some have computer backgrounds, some have very, very different backgrounds. All I need you to know is that what we're doing is we're accessing the thermometer on the microcontroller, and this is how we're doing it. And then we're accessing that data and we're reading it into this variable. Okay, that's it. That's all I need you to know. Now, next up, what we're going to do is we're going to create a while loop, and then I'm going to print that output to the plotter. So I'm going to do like we did before, while true, and then I'm going to say print, in this case, the thermistor temperature. So I'm going to access this variable, and I'm going to the temperature, and then I'm going to put a comma here. It's kind of quirky, but I have to put this comma here for it to plot out on the plotter. It's kind of interesting. So then I'm going to use the time sleep function. So remember, there's that time book, and then I'm accessing the sleep feature within that library book. In this case, I'm going to do a half a second. So this is 500 milliseconds. So I'm going to pause the while loop. Pause while loop for 500 milliseconds. Okay, that's all we're doing. Now, I'm going to come over here, and I'm going to make this a little bit bigger. Just a little bit, not too much, because I want the... there we go. All right. So this is good. Good spot for us right now. Now that we've got this written out, I'm going to upload this. So I'm going to hit save, and that's going to upload to here. It's going to go beep, beep, and then there it goes. You'll notice that the plotter switched over to a single line because what we're doing, and then I'm plotting on the serial view. I'm actually plotting out the Celsius. So over here on this side of it, I've got the 28 degrees Celsius, which is roughly 73-ish, 74-ish degrees Fahrenheit. And to check to make sure that this is actually working, what I'm going to do is I'm going to actually touch the sensor. You can cup it with your hand and then just kind of do this. And as you do that, you'll actually see the temperature immediately start to rise. So the serial, I'm going from 31, and I'm going to talk through this, but you'll see it completely start to rise. And this is actually just the warmth from my hand is getting picked up. And this will rise up to 34. I think it might top out at 34.5 Celsius, which is close. I don't know how close it is to the human body temperature, but that's pretty close to our running body temp. So it's slowly rising, and it's going up, it's going up, it's going up, and it'll keep going up. It's going to keep rising, and I'm gonna, once it hits 34, I'll stop. I'll just kind of pull it out, and then see I'm still holding it here. And there you go. So we're at 34, 34.1, and it'll keep going, 34.2, and we're 30. Yeah, we're kind of leveling out at 34.2. Maybe we might hit 34.3 here. We can see if it makes it 34.3. There we go. Okay, so that's good enough. I think we can stop. So I'm going to unclasp it. That confirms that our temperature sensor on our microcontroller is actually working. And if you blow on it, if you just kind of come up here and then the temperature is already going to start to come down like immediately. Okay, so there you go. I'm going to let it sit, and that's plenty for us to work with here. So that is essentially it in a nutshell. Okay, that's what we got to work with, and I'm pretty excited that worked without too many issues. You can actually create a function to make this work for Fahrenheit if you want to, but just kind of to put a bow tie on our lecture for today, because we're right at the 30-minute mark, or just a little bit past it. I do want everyone to kind of understand, and I'm gonna come down here and just do a quick lecture on what we're looking at here. So while that's running and working, and I just want to make a distinction here. So the TFT gizmo, we can make this what's called a bodied system. So so from an autonomous systems architecture perspective, I will talk more about this in our lectures later this week that I will publish. When we connect this, because this is connected and I've got this tethered to a system, if this code were running in the cloud, it would be an unbodied system. In other words, the smart code that I have running, I wouldn't call it an AI, right? It's not really an AI that we're running right now, not in the traditional sense. But it is it is smart code in the sense that we're accessing a library that has a lot more code behind it, and I won't get into all I won't get into all the specifics. But when we imported those libraries, those books from the library, and then we used features, there's a lot more code actually running behind it. We're actually using what's called a higher level general purpose programming language. And in this case, it gives us access to a lot more stuff with fewer bits of code, with fewer line items in regard to the code. You don't have to worry about all that. Just know that is what's going on in the back end. Now, if this code, I'll call it smart code, this smart code that we've written for the microcontroller, if it were running in the cloud, we wouldn't have access to the thermometer that's here right now. But we would be running that code, regardless, we'd be running that code in the cloud, and that would be unbodied code, right? From an autonomous system, it's not physicalized. So think of it more specifically like if I had a Tesla at a bigger level, like if I had a Tesla and I'm running autopilot, in the car. That's a bodied system. I have an artificial intelligence, I have machine vision, I have radar sensors, I have a whole bunch of stuff running, and it's all running within a physicalized car. So that's what we call a bodied system. Now, if I take our thermometer software that we built here and I run it, and remember, I got a battery that I can connect up to this, and then I'm using the TFT gizmo. We'll be using the TFT gizmo to output the thermometer's telemetry data to the TFT gizmo, and then combined with the battery, I can disconnect this, and then it becomes a bodied autonomous system. So that's what's kind of cool here is I can actually take this and and that's what we're going to do. We'll wire it all up. And then some. We'll do more than that. But a thermometer is nothing more. So, and this is end of lecture from this perspective. But a thermometer, in this particular case, is if we connect it to another physical mechanical engine, in this case, like say a air conditioning unit, that becomes a thermostat that autonomously regulates a physical device. In this case, an AC unit or an HVAC unit. An autonomous system does not necessarily, just to kind of give you some additional context, an autonomous system, in its purest sense of the terminology, again, we'll cover this in a lecture in more detail, in a purest sense, doesn't necessarily have to be a digital device. It can be a mechanical device. The idea of an automaton, there are different types of machines. There are solid state machines. There are finite state machines. There are different types of machines. We are working with digital machines. There are biological machines. Humans are biological machines, and we run biological code, i.e., using DNA as a programmatic code, and then our genotypes are information systems. When expressed through the process of us getting 3D printed, and biologically printed in a womb, right? We become these biological machines, and then we grow, and our code becomes programmed as we learn more, and as we are exposed to external stimuli, and so that creates training data, and that training data then becomes incorporated as code, and then we actually learn from our experiences. So we become autonomous entities or autonomous biological machines. I do want to, we will talk way more into that as we move along. But with that, I'm about 7 minutes over my mark of 30 minutes here. So this is a little bit longer lab, and most of the time our labs will be 20 minutes long. Our lectures the same way will probably be 15 to 20 minutes long. These won't be super long, but this one, because we had a lot of setup, we had a lot of things we had going on here, it is a little bit longer. Okay. I think I'm done. I don't have anything more to show or showcase. This is all we've got for right now. We will be using the TFT Gizmo more. We will be doing more bodied work, i.e. untethering we'll be doing more untethered work. For right now, we'll be doing a little bit of tethered work for right now. And we will get to more of the key concepts of an autonomous systems architecture through our hands-on learning with this. Okay, with that, I am done. Thank you for listening. If you have any questions, do feel free to please reach out to me at mjp001@ksu.edu or 785-979-0706. Both of those are both also in my our syllabus. So if you do have any questions, feel free to reach out. Otherwise, I will see you in the next learning activity.